Hello and welcome to a video tutorial for the BlackHole.Core.ORM, which is a .NET Core class library that I have created, and it's available on NuGet and on GitHub because it's an open source library. This is a lightweight ORM and easy to use. It supports out of the box 5 popular types of databases. It supports Sql Server, Oracle, MySql, Postgres and Sqlite3, and it has the same behavior with all of them. It has many features. It has a data provider with many methods to interact with the databases. You can select, insert, and update using the data provider. You can also select specific columns using a BlackHole DTO with the same methods. There are overloads on its method where you can use a generic BlackHole DTO with the same columns, with the same name and type. BlackHole will only select those columns from the table and it will map the columns to the DTO. This also works with update methods. You can use a DTO there. Another feature is BlackHole is able to perform joins with different tables without requiring a foreign key. You can perform joins without writing any SQL. It also has an interface for initial data if you want to have default data when you create a new database. BlackHole also has the ability to create the database and the tables on the startup. It also updates the tables if there are any changes to the entities. Another feature of the BlackHole is that you can use specific namespaces and specific class libraries or other assemblies in order to generate the tables from the entities that exist there. For example, you can have a modular application with many different namespaces that each one contains different entities, and depending on the settings on your configuration, you can generate different tables each time and create a completely different database. Also, BlackHole can automatically register services in the iService collection if your services inherit from specific classes that BlackHole provides. And we'll see all of this in this tutorial. In this tutorial, we are going to create an API, and using Swagger, we are going to test all the features of the BlackHole. We're going to explain everything, and also we're going to show how the BlackHole Core CLI works, which is another NuGet package here. It's a .NET tool, and it's an additional tool. It's not required, and it is for people who prefer to use the command line. It has 3 commands: the update, the drop, and the parse command. That was a long introduction. Let's jump into the project now. Let's jump into the tutorial. I'm going to use Docker to host my databases. We have Oracle, MySql, Postgres, and this one is Sql Server. We're going to start with Postgres. I'm going to start a Postgres instance here. And by the end of the video, we will see how the BlackHole can work with exactly the same way to the other databases without changing anything to our code. So I'm going to start Postgres, and I'm going to create a new project here on the Visual Studio. We're going to create a web API. Going to use this one. We're going to call it BlackHole tutorial. And here we are. We have started a new project. I named it BlackHole tutorial. And we have also the weather forecast here as a default controller. We're not going to need this for now. Let's start by installing the BlackHole into our project. We're going here, NuGet Package Manager, Let's browse and let's type here BlackHole.Core.ORM. As you can see, it's right here. Let's install the version 6.0.2. That's the latest by the time I'm recording this video. There are not going to be many changes to the next versions, and I'm only going to add new features. I'm not going to change anything to the existing features or to the existing interfaces. So if you have, if you build an application using this version, and if you want to update later, it will not break anything. So as we can see here, it has many dependencies, and all these dependencies are coming from the data providers, from the drivers for its SQL client. You see, you have MySql data, npm for Postgres. We have Oracle managed data access, SQLite, etc., etc. We're going to accept all these. There are some licenses here. Somewhere is the BlackHole license. Somewhere. Okay, it doesn't matter. Here it is. I don't know why it doesn't show it. If you want to see the license, you can go here in NuGet and click on license info, and you can see the license. This is for BlackHole Cli. Give me a moment. It's exactly the same. It's free to use, and you can use it anywhere. So now we have installed the BlackHole ORM into our project. Let's check here our dependencies and the packages, and as you can see, here is a BlackHole Core.ORM. And now, in order to create a new database, we need to come here in the program, and to add the BlackHole configuration, we need to add this statement using BlackHole.configuration. And this namespace contains everything we need to configure our BlackHole. So now we want to configure the BlackHole, and we'll go down here. We'll create some space just to be able to see it clearly. And we go to our services, and we want to add to run the method supernova, because if you want to create a BlackHole, first you need a supernova. And if you have a project like a console application which doesn't have services, by default you need to add a host to keep your iService collection. And here, as you can see, it has a red underline here because the command is not finished. We need to create a BlackHole settings. So we can type settings. We can name it whatever you like. Say settings, then lambda expression, then settings dot add database. And here we open brackets again. We open a parenthesis again, and we need the connection settings. So let's say here connection. Also this, you can name it whatever you like. You can type, for example, here x dot, and but I'm going to do it connection for now because I want it to be clear. Connection dot And here you choose the type of the database we're going to use. We are going to use Postgres in this video, so we will use npt SQL. We open parentheses again, and here, as you can see, it requires a connection string. So here I have added some connection strings for all these databases that we're going to use. And as you can see, I have added the name of the database in its connection string is BlackHole tutorial. You can name your database whatever you like. And the BlackHole will find this name on the connection string, and it will create this database. It will create a database with this name. Except for Oracle, where BlackHole is not able to install an Oracle database because an instance of the Oracle database it's like a server. You have to install Oracle manually if you want to use BlackHole with it. But for now, we're going to use Postgres, and here we're going to add this connection string. Of course, you can save these connection strings into the app settings, but now for this tutorial, I'm going to put them there as simple strings. And now we have no errors. If we want to use a schema with Postgres, we have an overload method here, and let's say we have a schema ESOP, all right, for our ESOP. And schema is available for Postgres and for SQL Server only, because in Oracle the schema is the username. Each user has a different set of tables, and in MySql the schema is the same as the database. And in SQLite, of course, SQLite is a single file, so I don't think anyone is going to use a schema on SQLite. If you noticed now, I don't have a connection string for SQLite because SQLite works a little bit differently. In SQLite, you just add here the name of the file, and it's going to be saved in the default BlackHole data folder. And now this is the basic configuration. We're ready to go with this. But I want to show you some more settings that BlackHole has. So right now we have no entities, but I can show you how you can use different namespaces. So after the connection setting, you can say dot, and you can choose use entities in namespace or use entities in namespaces. Let's choose this one, and here you can type the name of the namespace, the complete name, the full name of the namespace. For example, now if I had the namespace here, let's create a folder really quickly, and let's create a folder named ESOP entities. All right, and let's imagine we have entities in this folder. We can go right here. Let's create an entity actually. Add a class here. Let's create an entity. And let's say we have the customer entity. Customer.cs. Alright, and we created a class here, which is our entity. And to create an entity, we are going here and we say using BlackHole.entities. And now we have all the required classes to design our entity. So now we are going to make the customer and inherit from the BlackHole entity. And here, what is required, what is this G here, the generic type, is the type of the ID because BlackHole has auto increment in every table. So it needs to know what type of ID we're going to have. It supports integer, GUID, and string, and it generates the ID if it's required, or it uses an auto increment method, depending on the database type. So here let's make the customer use GUID. Why not? Let's use GUID entity here. Let's add some properties. All properties must be public in order to be accessed from the BlackHole. So let's say here first name, and let's put the default value to string empty, and let's add also last name. All right, this will do for now. And as you can see here, we have a namespace that is called BlackHole tutorial.isop entities, and we can copy this namespace here. And if we do this, now BlackHole will only generate tables from the entities that are in this namespace. So if we have another, let's create another namespace here. All right, let's say this is blog entities. Let's say we have an application that can transform into different applications. So we have blog entities here, and we can add also here a class. We can say user. We can have a user in the blog. Let's create the entity. And make it also inherit from BlackHole entity. Let's make this with an integer ID. The ID column is existing into the BlackHole entity. That's why you cannot change the name. You always will have an ID column that will be called ID, and you can only choose one of the three types that I mentioned: GUID, integer, and string. Which in string ID, BlackHole generates a hash that is created from a new GUID and the current datetime. So let's say here public string username. Okay. Let's say it has a username, and let's say it has a password. This user. Okay. I'm only making this entity to show you that it will not be created if we use a specific namespace here. Also, what else you can do with the settings? You can use add services from a specific namespace or specific namespaces. So in here, if we use namespaces, here it will require a list of namespaces. Then the same goes for the services, and I'll show you soon what I mean by adding services from a namespace. As I told you in the beginning, BlackHole is able to register automatically services to the iService collection, So let's create a service. Let's go and create a service. Let's add a new folder here, and let's say Sql Services, and let's create a new class also, and let's say it is what type? Customers, no customer service. Let's say that is the generic Sql service. Okay, that's our Sql service, and we can also generate an interface. Let's make another folder here for our interfaces. Sql interfaces. All right, and we can also add here another class, an interface, and we can call this one Sql service. So we have the service and the interface. Okay, and here we can go and add the interface to our service, Sql service, and it is always required to have the same name for the service and the interface using a capital I in the beginning in order to be recognized from BlackHole. And here, if we want this service to be automatically registered to the iService collection without adding it to the iService collection ourselves, we can say here using BlackHole.Services. Alright, and here we can add, let's say we want to create a scoped service, so we can add BlackHole scoped and then a comma to separate this class from the interface. And now this service, the Sql service, is going to be registered directly to the iService collection if we use this namespace. Or if we use no namespace, BlackHole will detect all the services and all the entities in this assembly. So yes, I'm not going to do the same thing for the services. I think you get the point here. What else we can do now? We can go here and see the other settings of the BlackHole. Here's the set data path method. The BlackHole has a default data path which is in the current users folder, but if you want to change that, you can use this method, set data path, after the add database method. Alright, and here you can put the complete path of the folder that you want BlackHole to store the data. We're not going to do this now. Also, BlackHole has a logger which logs all the errors whenever something goes wrong at the command. It will generate a txt file with the date, the time, the SQL command that tried to execute, and the error and the details of the error. So it has a complete description of the error, and you can disable the logger is enabled by default, but you can disable logging using this method here if you don't want BlackHole to generate any txt files. And also it has a logs cleaner. It's a thread that runs once per day. It runs 12 in the midnight every day. It runs once, and it cleans by default the logs that are older than 60 days. Of course, you can change the days of the cleaning. You can disable the logs cleaner and you can keep all the logs. You can disable the entire logging. There are methods for everything. So if you disable logging, the logs cleaner thread will also be disabled. Here you can set logs cleanup days, as you can see. What else you can do? You can set data path and also set the logs cleanup days. There, as you can see, there are some overloads here. All right. Let's put something here. As you can see, there are some overloads. In the set data path, you can set the data path. You can add also the cleanup days to this command. I know it's not very correct, but I was running out of space of how to put this command in the configuration. Also, you can set data path and disable logs cleaner if you add a data path and false into this overload. There are many configurations that you can do with this. Also, let's see about the assemblies. If you have different assemblies and you want to use a DLL and you loaded a DLL and you have the assembly, you can go here and use other assembly. And here it expects a different assembly. And if you do this, then it will not search the current assembly for entities and services. It will search the other assembly. Also, what else you can do? If you don't have this, you can use other assemblies. You can use additional assemblies. If you use additional assemblies, then BlackHole will scan this one, this assembly, and the other assemblies that you'll put here. And it's a list of assemblies. So you need to load these assemblies from a folder or wherever you store them. But for now, we're going for this simple configuration here. Okay. Let's go back to this configuration. Right. Let's move it to the following line to be more clean. And that's a very basic configuration. And in this configuration, we're going to use only the ESOP entities namespace to generate the entities here. So let me add another entity. Let's say orders. Let's create orders. All right. Actually, let's name it order. Order. Okay, because it's customer. Let's make it order. And save for now. Let's go to the order. We're going to do the same as we did for the customer using BlackHole.entities. And now we're going to see how to set up an entity. Let's say that we don't want to delete our orders ever. We never want to delete our orders. And if we delete our orders, we need to keep them. We need to keep them in the database, but not calling them, not getting them when we call the get entries method. So BlackHole has some attributes, and one of the attributes is the use activator attribute. This attribute will utilize an integer column in the table, which is called inactive, and it's it will be like a flag, and if you want to delete an order, if you run the command to delete an order, for example, from the orders table, it will turn this flag to 1, and it will be considered as inactive, and BlackHole will ignore it in all methods. So, okay, let's make this entity use activator. Use BlackHole entity here. Let's make it integer. Why not? Or string. Let's make string entity here. All right. And what we want here, we want a foreign key. We want a foreign key for the order to point to a customer. So our customer has a GUID ID. All right. So we need to make this foreign key GUID. So public GUID customer ID to know where this order will belong to. All right. And now, in order to create the foreign key, we have another attribute here, which is foreign key. Oh, that foreign key. And it has a constructor here where we need the type of the other entity. So type of customer. And also we need to say, we don't need to say it, but we can say if it's nullable. So if I put here false, it will not be nullable. It is a foreign key which is not nullable. If we don't use this, then it will be nullable. The default is nullable. But we want every order to have a customer. And if it's not nullable and we delete the customer, it will automatically cascade the orders of this customer. So this boolean here, if it's false, then this column will be on delete cascade. If it's true, then this column will be on delete set null. Okay, so if we use true here, or if we don't use this at all, then if we delete the customer of this order, this column in the database will be set to null. Okay, that's automatic. All right, what else has an order? Let's make public datetime. Let's add a datetime and order date. All right, and let's add another datetime order delivery date. Okay, we can also add public bool is delivered, so we can know if the order went there to its destination. And what else we can we can add a total price. Let's say it's a decimal total price. And what else? Public int total products. And what else we can add? Let's say it has also a QR code. Public string QR code. All right. And let's add a default value here. And let's say we want to make this column not nullable. Or wait, we want to make this column not nullable. We want to make this column not nullable. Not nullable. We have another attribute to set the column not nullable. And let's say we want this to be nullable. So we make a nullable datetime here. And let's say we want the QR code to have a length of 1,000 characters. The default character length of BlackHole, if you don't use any attributes, is 255 characters. But let's say we have a QR code here and we want this to be longer. So varchar, we have another attribute here, varchar size, and here we can add the size of the string that we want. Okay, this will only work on string properties. If you put it here, it will be ignored. If I put it here, BlackHole will ignore this, will not do anything. Okay, so that's our order. That's our customer. Let's add some more fields to our customer because later I want to show you the usage of DTOs. Let's add postcode or zip code. Let's say it's zip code. Why do you have two words for this? Same thing. Zip code, let's add address, or let's add street. What else can a customer? The country maybe? No, let's say we only ship the products in our country, so we don't need country. Let's say we need city. Yeah. We need a phone number. And let's say we need also an email. And we can also play with the varchar here. Let's say we have a varchar size here of 50 because it's a first name. How long can it be? And also here we don't want to have big columns in our database. We want to make it light. And let's say here the same for this. And let's make the email, let's make it 100 just for a change. All right, let's say this is 100 and this is 500. Why not? So now we have our configuration ready. This is our configuration for the BlackHole, and we also have some entities, and we have said to BlackHole to use only this namespace, and we have the connection string here, and our database here is running. The Postgres database is running, and now we will just open the pgadmin. All right, and then I want to run the application, and we can see what happens. We are expecting to see a database named BlackHole tutorial to contain two tables, one table customer and one table for the order. And also we expect to see a schema that is named ESOP. So I'm opening pgadmin here, All right, and here we have I have already set up some databases on this Docker instance of Postgres. So we expect here to generate a new database when we run our program. Let's run it and see what happens. Alright, so now it runs. Okay, we have the controller here. We will not use this controller for now, but let's see in the Postgres what happened. Let's refresh here our pgadmin, and as you can see, a BlackHole tutorial database was created, and if we open it and go to schemas, we have an ESOP schema, and if we open the schema and go to tables, we have the customer and the order table. Alright, and we can see the columns here. These are all the customer columns, and let's see. These are the columns for the order. Let's see the constraints of the order, and as you can see, we have a foreign key here that points to customers. Alright, and also its foreign key is named order customer, and then it has the schema name. Now let's select all the columns of the customer just to see if the lengths of the varchars are correct. So here we can see, as I told you, the default value of the varchar, the default length of the varchar is 255, but if we put the attribute varchar size, we can change the size. As you can see, the ID is the last column because the ID is generated at the end when BlackHole generates the tables, and there's also the inactive column, which is generated in every table, but it's not used in every table. That won't be a problem because inactive column is inside the BlackHole entity, and it's a private property, so you will not be able to access it anyway. You can only access this column from specific methods that refer to inactive entities. And let's see also our order. We can see our order here. Okay, we have timestamps. We have the customer ID here, which is a UUID, and we have also a ID, string ID here. It's a primary key, and it's a varchar 50 because the hash that we're using here is 40 characters length, but for safety reasons I used 50 length column. And alright, so far so good. We have already created our database with just one command here and a couple of classes here. And as you can see, BlackHole detected those two entities, but it didn't detect this one. This one is also a BlackHole entity. So if we stop the project now and let's go to the program and just delete this configuration here. Alright, now BlackHole should generate also this entity with an integer ID. Alright, so let's run our application again, and now BlackHole will update the database since it found a new entity. We're expecting here to have 3 tables. So the application runs, alright, and let's refresh and go again to our schema, to the ESOP, and now if we open tables, we can see we have the user, and the user has these 4 columns, which is the ID. Let me see. The ID is an integer, the password, the username, and the inactive column. So what I want to do now is I want to add some more columns to this table. And to do that, I'm going back to my entity, the user, and let's add some more columns. Let's add maybe an integer, which could be user type. All right. And let's add also a string, which will be user email maybe. Yep. And also I want to make these columns not nullable. Not nullable, and here not nullable. And to make things even harder for BlackHole, I want to go here and I want to add a new line. Let's give it the ID of 1. Let's type the password in this column. Let's say user 1 here maybe. And also add a 0 here because I want this entity to be active, this entry. Let's save the changes manually. And now I want to run this with not nullable columns and see if they will be added here. So we run again our test application. And the application is running, and now we can refresh. And let's go back to our tables, and as we can see, the columns are there. But wait a minute, are they nullable or not nullable? They are not nullable, and this one is an integer and has a default value of 0. And this one is a string, is a varchar. And let's see, it's not nullable and it has a default value of dash. So if I run, if I select everything again, view all rows, we should see that the line that we had inserted earlier has a 0 and a dash and has this new column. Now let's stop our application and let's delete again these 2 columns, these 2 properties from our entity, and let's run again and let's see what happens. Will BlackHole drop the columns? Let's run this again. Come on, you can start, you can do it. All right, our application is running, and let's refresh again to see if there are any changes. Come on, something's wrong here, something is lagging with my pgadmin. All right, refresh, and I see no changes here. What happened? Why didn't BlackHole drop the columns? Indeed, the columns are still there, the values are still there, and the reason why this is happening is because we're not in developer mode. BlackHole can only drop columns if it's in developer mode. Otherwise, it keeps the columns because to prevent any data loss. So let's go and put our application into developer mode. And to do this is very simple. We go here and we say is developer mode, and here we can add a boolean true to set it in developer mode. But If you want to add this in a configuration file, you can add something like a string property in the app settings, and then let's say we have a string that came from the app settings. Alright, and this string is dev, and we can do this. And now, using different app settings, we should be able, using different app settings, I mean if you have this string in your app settings, you will be able in different environments to use the developer mode. For example, you can have something different here in your production server. You can have this property to prod, so this will not get into developer mode. But for now, let's put it to dev, and this should have a result of true. And if we run this now, we expect these two columns to disappear. So let's run this again. And if we go here and we refresh, yes, and we check again the columns are missing from here. They have been dropped. And indeed, if we select everything again, and I probably need to close some of these tabs because they're slowing down the pgadmin. And we can see the columns have been dropped. So far we have seen how to install BlackHole, how to configure it, and how to create the entities, how to update the tables in the database and all the columns. So now all we need to do, the next step, is to interact with the database, to start using the methods that come with the BlackHole data provider. So we could do this in the controller directly. We could directly do this in the controller, but I prefer to use a service for that in order to show you what I mentioned earlier about the BlackHole services. So we come here in our ESOP service that we have already created, and we have to add the reference to this namespace, BlackHole.Core. And this is the main namespace of the BlackHole. Here are all the tools that you're gonna need. So we reference the BlackHole core here, and we want to make a constructor for this service. So public ESOP service, and here we want to add some interfaces. We want the BlackHole data provider interface, so we can add private read-only, because why not, with IBH data provider. And here you can see it takes two generic classes. One is for the entity, and the other one is for the type of the ID of the entity. For example, if I want to add a service for the customer, I should type here customer, and I also need to reference the namespace where the customer exists. Come on. All right, customer, comma, and since the customer has an ID of GUID, as I remember, yes, we should add here the GUID. We can name our service like something like customer service, and this is a BlackHole service. And if we do something different here, we're going to get an error because customer has a GUID ID column. So this prevents us from making a mistake here. And now everything is registered into the iService collection. This interface of the BlackHole is already registered into the iService collection here at this command. So we don't need to initialize it again. We can just use dependency injection, and we can say here IBH data provider customer, comma, GUID, customer service. And here we can say customer service equals customer service. And it's ready. We are ready to use the customer service from the BlackHole data provider, which contains many methods to help us interact with the database. So, for example, let's make an insert method, public GUID. I'm putting here GUID, and I'll tell you in a minute why I'm doing this. Public GUID insert customer. All right. And here we want to add a customer class. And here we want to return a customer service dot insert entry, and here we add our customer. So what this method does is that takes the customer and inserts it in the database, and it returns the ID. So here we get the ID from this entry, because as we said earlier, BlackHole has auto increment on the insert. For some reason I cannot see the descriptions here. Maybe something is wrong with the packaging, because I have added descriptions to every method and every class in the BlackHole, but for some reason after pushing this package to NuGet I cannot see the descriptions. I will find out what's wrong and I'll fix it in the next version, but for now we can work with this as it is. So we have created an insert method for the customer, but we need to generate a customer. So I will create a method here and call it a customer generator, right? Public customer. Want this to return a customer, and let's say customer generator. Okay, and now we are generating a customer here, and we want to insert this customer. And how I'm gonna do this is, instead of calling the customer here, I will put the customer here, and it will be generated from the customer generator, and I can add the customer insert the customer in the database. So I can make this method private, it doesn't matter, and we should also include this method in our interface, in this one. So let's include this method here, so we can call it from the controller. Let's create a new controller here. I don't want to mess with this one, so let's call this ESOP controller. Okay, and let's make a constructor here. Let's make a constructor which will take our service, and the service is private, read-only, ESOP service, ESOP service. Okay, let's include the namespace here, and let's use dependency injection again. And let's say underscore ESOP service equals ESOP service. All right, and as we said earlier, having this class here, having this service inherit from this class, it will be registered as scoped. Also, if we want a singleton, BlackHole has this class, and if we want a transient, BlackHole has this class, but we will stick with scoped now. Okay, so we don't have anything here to add this service as a scoped, and we just have this class here, which we will tell BlackHole to register this service and this interface as scoped into the iService collection. Let's give it a test now. Let's is everything in place? Yes. And here I don't want to return a view, sorry. Let's what to do here? Insert the customer, and here I want to use the ESOP service dot insert customer, and here I want to return a GUID in an action result. Okay, so I want to return a GUID here, and also I didn't put the method attribute. It's gonna be an HTTP post. Alright, I guess now we will see the endpoint on Swagger. Let me see. And now it's here. So if we try this, we should a new customer should be generated and should be added to the database. So let's go here to customers, just to be ready for this. I've cleaned up the windows here, the tabs, and let's test this method. And we got a GUID back as a response, and we should check the database now, and we should see that a customer with this ID was inserted. Let's see all the rows here in the customers, and And indeed, we have the customer, we have the values that we have added, and we have this GUID, which is the same as this GUID. All right. Is it? Is it though? What the? Huh? What the hell? Oh, sorry. The response. Yeah, we have this GUID, which is the same with this GUID. Now let's do some more stuff. Let's insert a different customer, and I want to go here and change this name to George, and let's say here it's add, and there's a reason why I'm changing everything here, because I want to use other methods later to search these entities in the database. I could create a generator, a random generator, but we are not going to insert many entries now, so we will do this manually every time. And let's run this again, so we can insert a different customer in the database. So we run this. Let's post again. We've got a different GUID this time. If we run this again here in the database, we will see a second customer has been added with a different ID. Let's make this a bit bigger. All right, I think this time the IDs are matching again. And now I want to do something different in the controller. I want to get the customer this time. All right, so let's make an HTTP GET here. HTTP GET, and we will make a public action result, and this time I want to return a customer. Okay, and yes, I guess we need to also add a reference for the namespace. Get customer by, I will say by ID for now, but later we're going to change it. GUID ID, and now we are going to use the same service to, yes, actually don't have an interface, we don't have a method for this yet into our service. We should create a method here, customer. We also need to add a reference to the namespace of this entity. Get customer by ID, GUID customer ID, yes. And now let's go here and also create a method. We can implement this method from the interface, and here we can use the customer service dot get entry by ID, and we can add here customer ID, and this will return the customer also. This may be nullable, so we should make it nullable, because if it doesn't find any customer, it will return null. So yeah, let's change that in our interface too. And now we should be fine here. Perfect. And now here in the controller, we can say service, get customer by ID, and add the ID here. Also, this may be nullable. This may return null if it doesn't find the customer. And let's run this again. And this time I'm going to copy this ID and use it in the Swagger to see if we will get the data of the customer. So we have this, the get method, and it requires an ID. Let's try it. Let's add the ID here. I think it needs this double quotes, and let's execute. It doesn't take double quotes. Okay. Alright, so we got the customer and it looks correct. Is this the correct customer? Yes, it's me. This is me, Southampton, Shirley, and we get the data of the customer. Let's change something here in order to return null. Execute. And now we got null, I guess. I don't see anything here. Alright, and now let's try this ID. Let's try this one. We should get the other customer. Execute, and we have George in this case. Alright. Let's make another method here. And let's find customer by name. And because I don't want to create every time a new method in our service, the service was only for demonstration purposes to show you that it is getting registered to the iService collection without adding anything here. But now we don't need this service anymore because BlackHole B8's data provider is already a service. So we can say private read-only B8's data provider, or I could copy it from the service, but anyway, and we can say customer service. All right, and we can also add here BlackHole core namespace. Okay, and here we can say IPH data provider customer GUID customer service, and here we can say customer service equals customer service, and we don't need this anymore. We can delete this. We can delete this from here for now. And here, instead of ESOP service, we can use customer service. Yeah, no, we can't, because actually we generate the customer in the other service. So we're going to keep this for now. But we want to create another method here, another HTTP GET with maybe with a different route here, and we can say route, and we can say by name because we want by first name. And what we want to do is to get customer by first name this time. So public action result, if I could write, it would be easier. Customer, it's a question. Customer, get customer by name, and here we're going to add string first name, okay, and return customer service dot. And what if we make this async also, to show you the async methods, because BlackHole has also async methods for every method has an async overload, let's say. So return wait, customer service get entry async where. So now we're going to use the custom Linq queue that is included in the BlackHole, and we're going to say where x dot first name equals first name, and then this is going to bring us the first entry that we'll find where the first name is equal to the name that we're sending. If we want to bring more entries, we can just change this method and say get entries, and this will bring a list of customers. But now we want to return one customer, so we are going to use get entry. It's that simple. It has countless methods. It has over 100 methods, I think. If you add the overloads, you can see here all these methods in the data provider. You can update, you can get, you can insert, and every method has overloads with transactions, with DTO mapping, and maybe we can I can show you the DTO after this one. So right now let's run this and let's try to get the customer using the first name. So now we have another get method here, and here it needs a first name. Let's try it. Let's type Mike here and execute. And wait a minute, I think it doesn't like this. Alright, let's execute again. And now we are getting the customer. We are getting all the information of Mike, of me. Alright, if we change this and we type George, alright, let's type here George, we should get George here from the database. So the Linq queue works. And now we want to pull some of the columns. We may not need all these columns, right? and we want to pull some of the columns of the entry that we are interested for. So I'm going to create here a new folder, and I'm going to name it DTOs. DTOs, that's better. Okay, and here I'm going to create a DTO for the customer, which will only contain the address information, maybe, or not. Let's see what we can do to make it more clear. Let's make the first name, the last name, and the email. All right. So let's make a DTO. Let's say customer DTO. It's a data transfer object, and we are going to create a DTO here, and we are going to make it inherit from the BlackHole DTO class. All right. And yes, wait. Let's do it manually using BlackHole.entities again. The same namespace. We can create a BlackHole DTO, and since our customer has a GUID ID, we need to make it with GUID as well. And let's go to our customer to copy some of the properties there, because in order for the DTO to work, it needs to have the same names and the same types of properties as the entity. If you have a different name, it will not be mapped, it will be ignored, and we will see this in a moment. If you have a different type of a property but the same name, it will also not be mapped. So here we just want this. Okay, let's go to our DTO. Let's add this one here, and we want the last name too. Okay, let's add this one here, and we also want the email. All right, just these 3 columns. Okay, so we have our DTO. Here we can go back to the controller and create another method, and we can name it, let's say again, HTTP GET. All right, and route. Let's say again by name. Get contact by name, or email by name. It doesn't matter for now. So public action result, and we want to get the customer DTO this time. We want the customer DTO this time. Come on, show me the namespace. All right, and get customer email by name. So we will send the name again, but this time we expect to get a customer DTO with only these 3 columns plus the ID column. So return customer service dot get entry where, because now it's not an async method, we don't need the async, get entry where, and now we are going to add here as a generic the class that we have created of the DTO. And again, x dot first name. Maybe we can do it with the last name this time. Last name equals, and let's change it here too. Let's make it last name equals last name. And of course this can be nullable. Okay. And let's run this again. And now we expect to get a DTO. And by getting the DTO, it also means that our BlackHole is only selecting those columns from the database, and it doesn't select the whole table. Alright, so this is the new method. Right, we want the last name now. We are going to get this last name from here and paste it here after I press try and execute. And indeed, we got only these 4 columns, which is the first name, the last name, the email, and the ID. We do this again for our other customer. Again, execute, and we are getting George Markinson and the other email and the other ID. So the same goes when you want to update something. So for the next part, I am going to update some of the values here, and we are going to create a new class. Of course, we can update using the entity directly, but I want to create a new class for the update. This class doesn't have to be DTO. We can create just customer update street address. No, location, customer update location class. All right, and here we can go to the customer again, because we need the same names. All right, we need the same names of the properties and the same types of properties. And let's copy these 3 properties: zip code, street, and city. And here we will go back to the controller, and we will create another endpoint here, HTTP post, and we can route its update location, and we can create here a public action result, which will be boolean, and update customer's location. Maybe I don't want to add any inputs here, or maybe I want to add some inputs here. Let's see. All right, we want a string, not a string. Let's add a GUID, or maybe we should do it again with last name, maybe, because I want to use also the custom link queue that BlackHole has. And here we want customer update location class, customer new info, and here we are going to return a customer service dot update entry. Wait a minute. not by ID, update entries where, alright, update entries where, and here we want to use the customer location as a generic class in order for these columns, these properties to be mapped to the customer properties. And here we need to say again the lambda expression where last name equals last name, comma, and now we need to add the new values, customer new info, and that's it. Now I guess we don't need this, alright, but I just wanted to show you that this exists. So now when we call this endpoint, it will take the values from here and put them to the customer with the name that we specified here. So let's run this again. And of course it will return a boolean. If it succeeds, it will return true, and if it fails, it will return false. So here update location, and it needs a last name, and it also needs a request body. So we are going to use this last name here. We are going to copy again. We're going to paste it here, and let's add some different values here. Let's add 555, 555, and street is maybe which street I should use? Something Arthur's Street, and city of Brighton, maybe. And let's execute this one. And we got a true response. That means that our call succeeds. So if we refresh here, we should see 555 and Brighton and Arthur's here. So let's run this. And indeed, this entry has been updated. And only these three columns have been updated. So we have seen how to insert entries, how to select entries, how to use the DTOs, how to update specific columns, and I'm pretty sure you can find out what every other method does. I don't have time to show every method here, but I think you can play around with all the methods of the data provider and you can find what its method does. I also am going to fix the description problem to the next update pretty soon. In 6.0.3 update I will add the descriptions that already exist, but for some reason they didn't get included in the package. Let's move to the next feature of the BlackHole, which is joins. And to do some joins, we need to insert some orders, and maybe I'm going to create another class here to make it a little bit more complicated. I'm going to make a class named orderLine, because every order may have many lines inside. So let's create a class orderLine, which it will be an entity. So using BlackHole.entities, and we want this class to be what we want it to be. Let's use an integer ID. All right, what is this? That's a string, that's an integer. All right, we have one of each type of ID. So what an order line could have? Let's have a public string product name get set, and also what we need is a foreign key to the order. So let's make a public string order ID, because the ID of the order entity is string, and here we can add foreign key type of order, and let's make it also not nullable, so false, and let's add a default value because I don't like these warnings. String empty, and let's add public int quantity maybe, and what else? Public decimal price. All right, and I think these are enough for now. So I am going to run again the BlackHole in order to create the table. All right, let's run BlackHole again. It runs, and if we refresh here, we should have the table order line with these columns. All right, perfect, and it should have a foreign key to the order. Perfect. Now, what I want to do is to create in our service. Let's go to our service and create another private method, but this time we use order because we want to generate an order, and maybe we can use the total products to add some order lines here for this order. So let's create another private method, list order lines, order line actually, and order line generator, and let's add an integer here, total products. So we are going to generate this number of products here, and let's create a list of order line, and order ID is, wait a minute, we need an order ID actually, string order ID, because we want this to belong to the same order ID. And now we should just return the order lines. So now we can create a method to insert an order and generate an order and its order lines, and then what's happening in the database. So we want a method that we will actually, you know what, let's make a GUID here and customer ID and replace this one with the customer ID to create a chain reaction. And now let's make a public method, and what we want to do is let's make a void, right? Insert order for customer. Let's add a GUID here, customer ID. So this way we can add multiple orders and changing the GUIDs from the controller. And here we want to generate, we want an order equals order generator, and we can add here the customer ID, and then we can say string order ID equals, we don't have an order service, right? We need an order service. Yeah, private read only IBH data provider order string, comma string, and this will be our order service. Nice, and the same goes for here. We need an IBH data provider with order, comma string. All right, and order service with dependency injection, and here order service equals order service, and now we can say order service dot insert entry order, and we are going to get an ID, or maybe we may get a null value, but I guess the ID will be inserted correctly. So if order ID, actually, you know what, string is null or empty, order ID, let's make sure it's not null or empty, this ID, because if the insert fails, you will get back a null value or a string empty. So order ID, insert entry, order service, insert entry, order, and we are going to get the ID, and now we are going to generate a list of order line. All right, order lines which will have the order ID inside them. So generate order line generator, sorry, and it requires total products, so we can say order dot total products, and it also requires the ID, so order ID, and we will get a list of order lines, and now we have to create also a service for the order lines, private read only IBH data provider order line, and since it has an integer ID, we use int here, and order line service here, and also we need to add this into nice, I didn't know you can do that. And now we have an order line service. We can do a list int order line IDs equals order line service dot insert entries, but this method is not asynchronous, And what we're doing here is we are generating a new order, and with taking the ID of this order, which belongs to this customer, and we insert the order, we get its ID, and then we use this ID to create order lines, and then we insert these order lines into the database. And we could return a list of integers here, just to see the IDs of the order lines. So list int order line IDs equals new list int. Alright, and we can delete this one from here, and we can return the order line IDs. Okay, now all we have to do is to add this method to the interface of the service. So we add this method here, and then we have to create an endpoint to the controller. I will call this endpoint, let's make another HTTP post, and let's add a route, insert order, and here we need a public action result list integer. Alright, and insert order for customer. Let's add a GUID here, customer ID, and here we want to return the ISOP service dot insert order for customer, and here we can add GUID of the customer. And let me see something. What's wrong here? Oh, it's not action result. Now it's fine. And let's run this again. And now we will copy this GUID, and we're going to add an order for this customer. So here we have another method, another endpoint, and we want to insert an order for this customer, and we're going to paste the ID of the customer. We will execute this, and I hope we will get a list of integers. If the list contains zeros, then the insert failed. So we got a list of integers. These are the IDs of the order lines, and if we go to the database now, we can check the order. Let's view all the rows in the order table. And as you can see here, an order has been added. This is the hash that I was talking about if you are using a string ID column. And if we see also, the order lines should have this hash as their order ID. We should see 5 order lines now with integer ID. You can see here 1, 2, 3, 4, 5, and they all belong to this order. And of course, this order belongs to this customer. Now that we have an order and the order lines that belong to a customer, we can get into the most complicated part of BlackHole, which is the joins. To create joins, we need to map them somewhere. So we need to create another DTO for this. I want to join the order lines to the customer. So I am going to create a new DTO here. Add a new class, not in the controller, sorry. Let's go to the DTOs and add a new class. And let's call this order lines of customer DTO. So we are going again to use the BlackHole entities namespace. So using BlackHole.entities. All right. Entities, sorry. And since we are going to start our join from the order line, we can create here a DTO of type integer. So BlackHole DTO integer. For now, let's add some columns that we want to see in our joins. So let's add public string first name to get the first name of the customer, and maybe public string last name to get the last name of the customer. Let's say we want the order date, say public datetime order date. We can add the QR code, maybe public string QR code. The names of the properties of the DTO must be the same and as the names of the properties of the entities in order to get mapped correctly. So if I make any mistake, it will return null to this property. What do we need from the order line? Maybe we need the product name. Let's go here and add the product name. Of course, we are going to get the same product name because every order line has the same product name inside, but okay, let's also get the quantity, maybe. The quantity, let's go here, let's add the quantity, and also let's add the price. So let's add the phone number of the customer here. And this is our DTO. Let me add some default values for these properties to stop the warnings. All right. And also what I want to do is I want to make the price a string, and maybe also, no, let's leave the price for now, right? Because I want to show you how you can cast some properties into a different type. And this is the DTO that I've created. We can go back to the controller and create another HTTP GET, and let's add a route, customers order lines. Let's add a lowercase c here, and public action result, and we want a list of order lines of customer DTO, and get order line of customer, and let's add here a GUID for the customer, right? And now what we want to do here is to start the join process. And to start the join process, we're actually going to need, since we are starting the join process from the order line, we are going to need the order line service. Of course, we could add this method into the ESOP service, but it's okay if we add it here. Alright, and now we have the order line service into the controller. And here, now we can say return order line service, because we want to start with the order lines, as we said before, and we want to start an inner join. So inner join, as you can see, there are all the available joins. If we want to say right join or left join or outer join, but we want to do for this tutorial the inner join. And now we need to add some generic classes to specify what type of join, which tables we are going to join. So the first table, because we started from the order line service, the first table here is already the order line. So we need to specify the second table, which is the order table. Then we need to specify the column, the type of column that we are going to join these entities on. So the order has an ID of string, so we are going to connect these entities with a string. And here we need to specify the DTO that we want to return. So order lines of customer DTO. And now we need to specify the columns that we are going to join. So X, this X is for the first table, which is the order line. So as you can see here, we have the properties of the order line. So X dot order line, order ID, because we want to join the order line with the column order ID to the order. This is the second table, and as we can see here, we have the properties of the order entity, and we want to join with the ID. If we want to join in multiple spots, in multiple columns, we have also a method for end, and here we can specify some other columns, for example, and it doesn't matter the key. Here we can specify the product name with the QR code of the order, but we'll not get anything if we do this now. So let's delete the end. Also there's OR, which does the same thing. If you know SQL, you will get the point, but for now we'll just want this. And to proceed, we just type then, and we can either execute this and get the result, or we can proceed to the next join. If we execute this now, execute query, we will get the result, a list of order lines of customer DTO, but we want to also join the customer here, so we are going to make another join. So then dot inner join on is another extension method, and this time, because it's a separate join, we require both tables. This extension method does not depend on the service, so we need to specify both the tables that we are going to join. And the first one of the tables is going to be the order, and the second one is going to be the customer. And we are going to join this with a GUID because the customer has a GUID ID. And unfortunately, we need to specify again the DTO. If we put a different DTO here, we will get an error. So if I put here customer DTO, it's not going to accept this. We need to add the same DTO with the previous join, and now it recognizes the method. And here we want to do the same thing again and join the customer ID of the order to the customer's ID. And since we are getting a GUID from our controller, from the Swagger, we want also to add a where statement here. And as you can see here, we have a where first and where second. The where first refers to the first table of the join, to the order, and where second refers to the second table of the join, the customer. So we want to add where second. Where second x.id, and this is the ID of the customer. If we go here, we can see this is the customer, where x.id equals customer ID. Also, here's the tricky part. We cannot change the order of these two entities because in order for this join to work, we need the first table to already have been used in the previous joins, in some of the previous joins. So if we change the order here, BlackHole will ignore this entire line. BlackHole will ignore this join and will move forward to the next. It will only perform this join and all the other correct joins. So in order to perform a join, the first entity of the join must have been used at least once in the previous joins. As we start the join, we already have an entity, which is the order line, because it comes from the service. So we have order line and order. So here, as the first join, in order for this to work and not be ignored, we need to use only one of these two entities of the order and the order line. Now, this is the join I want to do, and now to finish this join, we type then, and as we saw earlier, we type execute query. And now this is going to return an order lines of customer DTO list. But if you remember, there's a difference here in our DTO and in our order line. The difference is that the price is a string in our DTO, and in the order line it's a decimal. So we want to cast the decimal to a string, and we can do this by going here to the end of the first join and run the method cast column of first, because the order line is our first table in this join. So cast column of first as, and here we can say x.price, and we will cast the price. As you can see here, the first entity here is the order line, and then the other object here is going to be our DTO. So we want to cast this property here to the DTOs, price. And this will work even if we change the name of the DTO. If we say here prices, for example, and we'll go here and we say prices, prices. Okay, this will also work. We can use the cast to cast any column to any property of the DTO. But it has some restrictions, of course. You cannot cast a string to a datetime or a number to a datetime or a string to a number. You can only cast, can mostly cast numbers to numbers and all the other values to string. And this is for security reasons, in order to not break anything during the join. So you can cast almost everything into string, but you cannot do the opposite for everything. Also now, if we had entities with the same ID, we could, using the cast method, we could cast the ID of a different entity to the ID column of this DTO. But since we have different types of IDs to each entity, we're not going to do it now. Let's run and see if this is going to work. So I'm going to copy the ID of this customer, all right, because the orders we created are on this customer. And I'm going to copy this ID, and I'm going to run to call this endpoint of the controller using customer's ID. And we expect a list of this DTO. We expect to see the order lines with the first name, the last name of the customer, the date, the QR code, the price, the phone number. All right. So let's execute this. And as you can see, we got all the order lines, and you can see in each order line we have the first name, the last name, the order date. This comes from the order. From the order, these two come from the customer. This also comes from the order. This comes from the order line. This comes from the order line, and as you can see here, the price it's a string. We casted the price of the order line into a string. We have the phone number from the customer, and it's correct, yes. And this is how you can perform joins into using BlackHole without a single SQL command. Since we have successfully made this join, I want to show you how you can store this as a view and then call it with wasting less resources on your computer, because this is a heavy process to translate all these commands into SQL. It's a bit heavier. It's still fast, but you can make it even faster. So let's make here an HTTP post. All right, let's make an HTTP post here. Another route, another route, and let's say this route is store customer order line view. Of course, it would be better if you were making a method on the startup of your project in order to store this as view. This is saved into the memory, but for this tutorial we're going to use a command from Swagger. We're going to make a call from Swagger to store the view, and then we're going to make a call to pull the view, to get the view. So public action result again, action result, and here we want to return an integer. The integer is the index of the view in the view storage where it's getting stored. So store a view, store order line view. We don't need any inputs for this, and we are going to copy this, the whole join. We're going to copy this, we're going to paste it here. All right, but instead of execute query, we're going to say store as view. All right, and this returns an integer, which is the oh, we need the customer ID. Sorry, we need the customer ID. This returns an integer, which is the position of the stored view, but we are not going to use it. It's just for demonstration. You can call the stored view by the DTO using just the DTO for now. So we will store this as a view, and we are going to make another endpoint here, http get, and we say route get stored view, and we make a public action result and a list of order lines of customer DTO get stored view of customer. And now we are going to include another interface here, which is the IBH. Let me type it. Read only IBH view storage, and this is going to be our view storage. All right, and here we also need to add it with dependency injection. All right, and now here, using a view storage, we can return view storage dot execute view, and here we need to add our DTO. So we paste this here, and let me see, we are good to go. So now I will hit this endpoint to store the view, and then I will hit the other endpoint to get the result that we got earlier by this join. All right. We should get an integer as a result. I think we should get 0 because there are no other views in the list. So store customer order line view. So we will also copy again this, copy this one, and let's go here and let's try this one, store customer line view. We're going to paste this, we're going to run it. We're going to get 1, okay, and now we're going to close this, and we're going to get stored view, and we will just execute it, and we are getting again the result of the joins before, because we stored the joins as a view, and now we can get it over and over again. See, we can clear it, we can execute again, and we are getting the result of this stored view. You can see here is a different method, and if we run this one again, with the customer's ID. You see, it took a little bit more time to execute because it was translating the commands, the joins, to SQL commands. But if you have stored it as view, it's way faster. Look at this. Look at the difference. Oh, no, now it's fast too. Okay, all right. And what happens if we run again the store view? If we run again this store view, if we store the view twice, actually what BlackHole does, it replaces, if it finds the same DTO in the list, it just replaces the old view with a new view, so we're not going to get any different result. We still get 1 because it removed the previous view and in its place added the new view. So again, we are going to get the same result. Every command that we have used so far, it's a simple command. It translates into a simple SQL command, and it has no tracking or no transaction involved, except this command, the insert entries, which is a mass insert command, which is using a transaction internally, but the rest of the commands are autonomous. For example, this one is separate than this one, etc., etc. What I want to do now is I want to create another method to insert, to mass insert order lines, but this time I'm going to use a transaction. So let's go here, let's copy and paste this method from our ESOP service. And now what we want to do is to rename it and use a transaction in here. To use a transaction with BlackHole is very easy. We have a disposable class for this. So we type using and bh transaction equals new bh transaction, and here we can add all of this here. And now what I want to do is I want to add this transaction into every command. So comma transaction, and here comma transaction. So when we are in a transaction scope, this object, the bh transaction, contains a connection and a transaction, and when we run this overload of the commands, the overload with a transaction, then this command doesn't create a new connection, but it uses the connection of the bh transaction. So we have the same connection and the same transaction, and we can use this object in every BlackHole command, even in the joins commands. So let's copy this method to our interface, and we are going to create another endpoint to our controller, and we are going to insert another order for the customer using the transaction this time. Alright, let's make an HTTP post. Let's the route here. Let's call this route insert order with transaction. Alright, and here we expect list of integers, because the order line IDs are integers. So action result list int, and let's call this method insert order with transaction, and we require a GUID, which it will be the customer ID. And now all we need to do is return shop service dot insert order for customer transaction, and here we're going to put the customer ID, and we could test it right now. Let me open very quickly the database here. Let's go to the orders. Let's see the order that we have created earlier. So now we have one order here. Let's go to our customers, because I want to copy the ID of the customer and use it to the API. This time I'm going to pick this customer, and we can copy it, and let's run our application, and we expect to see the same behavior because we have no errors. But I'm going to make an intentional error, to create an intentional error, to see that if something fails in the transaction, then nothing gets inserted in the database. So let's go here. Here is our new method, insert order with transaction. Let's try this. Let's paste here the ID of the customer, and let's execute. And we got the IDs of the new order lines, which are in a sequence. And if we run this again, you can see that we have another order with a different ID. And if we go to the order lines, the data here may be the same because I'm using the same generator, but the ID is different. And if we go to the table of the order line, we can see we have 10 order lines right now. And these 5 order lines are connected to the second order. Now let's make an intentional error. Let's go here in our service, and let's also create an order line. Let's make a generator, order line generator. Let's create a fake order line. Let's order line error order line generator, and here we're going to add to create a new order. Let's return new order line, and we can copy all of these. Here, but instead of order ID, I want to insert something here which is not an ID of an order. So we will get an error on the foreign key here, and we should see our transaction failing. So let's go right here and generate another order line. Sorry, generate error order line equals error order line generator. This will create this order line, and now what we're going to do is order line IDs, add order line with order line service dot insert entry, and here we want to add the error order line, and we also want to use the same transaction. The transaction here gets committed on the dispose, so you don't need to commit. But if you want to commit earlier, you can do this transaction.commit, and this will not affect the transaction, because if you do any action before the disposal of the transaction, then in the disposal it doesn't do anything. It doesn't do any actions. It just disposes the connection. So there are some commands here on the transaction. You can do commit, you can do rollback, and you can do do not commit. These are 3 commands. So if something fails, you can either do a rollback if you want to revert everything and do something different, or you can do not commit, or you can do the commit if you want to commit earlier. And you can run commit multiple times. For now, I'm not going to use these methods because I want just to commit the transaction, and if the transaction fails, it will automatically roll back everything. So let's say for now we have an error order line here, which has a bad foreign key, and we can run this again. And we can test again this controller. We will go here and copy again the ID of the customer. So this is our method. Let's try it. And we're going to paste the ID of the customer. And if we execute now, you see, we're getting the IDs, but the last ID is 0, which means we got an error. And if we go here and we select again the order lines, let's see, we can see here that the new order lines, the 11, the 12, the 13, the 14, and the 15, are not added here because the transaction failed. So when we are doing a transaction, is everything or nothing. So if I go here to the orders, wait, let's go to the orders tab. Here's the orders tab, and if I select everything again, we can see that neither of the order has been added because one order line failed in the transaction and everything else rolls back. Since we generated an error here, now it's a good opportunity to show you the logger, the logs that are created every time you get an error, because a black hole will never break anything. It will just print the logs and it will return a null result. As we saw earlier, we got a 0 for this insert. We got a 0 ID as a return for this insert because the default, the null value for integer is 0. So let's go here. I have a folder which is named BlackHole data, and if we check the path, Now it's in users, my user, and then BlackHole data. This is the default path. If I change the default path on the configuration, it should generate this folder somewhere else. And here we have some other folders. We have the logs and the SQL files. This is empty right now. This just generates files when you are using the BlackHole CLI. Here is where it stores the SQL files of the commands that create the tables in the database, but we didn't use CLI yet. And here is the logs folder, which we have the error that we just saw. And if we open this txt, we can see the date and time here. We can see the command that it was trying to execute. So the command was insert into isop.orderline all this order, or all these values here, all these columns and these volumes, and it's returning the ID. And this command failed, and here we got the error, and here we have the details. So this is how you can troubleshoot BlackHole. If you are getting a null result and you don't know the reason, you can go in this folder and in the logs folder, and you can see the logs that are generated there. So these are all the basic functionalities of the BlackHole Core.ORM, and the next part I want to show you some extra features. And to do this, I want to create another entity here. So let's create a new entity, and let's call this entity discount. If you let me write. Right. Let's create a discount.cs. Alright. Let's create a discount table, a discount entity, and we are also going to make this BlackHole entity using BlackHole.entities, and here this should inherit from the BlackHole entity. And let's make this a type of integer. Why not? To make things easier. And what I want to do here, I want to add public string first name get set. This will be the customer's first name, and public string last name. Remember also to put the attributes here because we want this to be exactly the same as the customer attributes. So let's copy this varchar size. Let's go here and let's paste this here and here. Alright, so now both of these properties are have a length of 50 in the database, and here string empty. Alright, and now what we want to do is to add the public decimal, and let's call this discount percentage set. Alright, or let's make an integer to make things easier. So we have this table which doesn't have any foreign key to the customer, but this will contain the first name and the last name of the customer. So if I run this now, this table should be created in the database. I'm going to run this, and I'm going to refresh the database so we can see that the table is there, and we have the table discount, and it contains the columns, and we can see here the constraints. We don't have any foreign key, we have only the primary key of the ID column, And now what I want to do is let's stop this. No, yes, let's stop this. I want to add here, I want to go to the discount, and I want to add manually a new line to save some time. So I'm going to add manually the first name of this customer. No, actually, that's the last name. Okay. Okay, let's copy this. Let's go to the discount. Let's add a new line. Let's paste this here. Okay. And let's type here Mike. And let's add a value here, 0. And let's say the discount percentage is 10% and the ID is 1. And let's save this. So now if I select again, we have this line here. And now we want also to include the discount percentage to our DTO when we join. So without any foreign keys, we are going back to the controller. Actually, we are going back to the DTOs. And let's go here to the order lines of customer. And let's go to the discount. Let's take this property. Let's copy it and paste it here. All right. And let's run this. Let's run this without changing anything here to the join. All right. To see the result before making the join. Let's test it. All right. And where's the join? This one is the join. So let's go here to the customer. Let's take this one. No, this is not the customer, sorry. This is the customer. Let's take this ID and let's go back to our Swagger. Let's paste this here. Let's execute the join. And as you can see now, we have a 0 here, which is the null value for integer, because it didn't get anything from the table. We didn't join the table, but also didn't break. It just returned a null value here. Now we are going to join the discount table with the customer table, and without any foreign keys. So we will go here and say inner join on, wait a minute, yes, it requires then to end the previous join, then inner join on, and here we are going to put the customer first, because the first table must be already existing in the previous joins, and then the discount, and we are going to join them on a string, because the columns that we're going to compare are strings. And of course we want the DTO, order lines of customer DTO, and here we are going to select the customer first name, that we want this to be equal to the discount dot first name, and we also want the customer last name to be equal to the discount dot last name. last name. So now we are joining also the discount table, and since we have a common column between the DTO, we have this column, and the discount, this column, since we have the same columns into the entity and the DTO, BlackHole will automatically find that this column should go here in the DTO. So we have created a discount. We should see 10 as the discount percentage. If we pull this information from this table, and let's run this again to see if the join is correct. We are going to paste here the customer ID, and we are going to execute, and we can see a 0. What? Damn it! I've stored this to the stored view. That's why we got an error. We didn't got an error, actually. Let's cut this from here and paste it here. Oh my god, and I thought something was broken. Alright, now let's save this and run again. And now we should see the 10 value in the discount field, in the discount property. So let's run this order line, try it out. Let's go here, let's copy again the ID of the customer, let's go back to the Swagger, let's paste it here, and let's execute. And now we can see that the join has been made. Yeah, and we joined another table into our joins, into our view, without requiring a foreign key. It's like you are you're writing SQL using C# code. So there are a couple of more features that I want to show you before we move to the CLI tutorial, to the BlackHole CLI tutorial. And the next feature is that BlackHole has some helper functions. So let's make another endpoint here just to show you the helper functions. Helper function test, maybe. And what we want to return here, let's add action result, and let's return here discount. All right, get discount by customer, maybe. And here the helper functions are used in the where statement. So return discount service. Do we have discount service? I guess not. So let's go here and add the discount service. Discount service. Perfect. Now we can go here and say discount service dot get entry where. All right. And here, what we can do is, what we have is that, wait a minute, we need to set a field. So let's say x.lastname, and then we have some functions here. We have, not these functions, wait. We have, why are all these here? Let's type SQL. All right. The methods that BlackHole provides start with SQL, So now we can say, we can check the length. Here we have the length, which translates into an SQL length command into the where statement. So length equals 5, for example. So this should return the first entry that it will find, and the last name will have 5 characters, for example. Or we can directly compare it to a customer or to any other table. If we say SQL equal to, and here we can add a generic class, a generic entity, customer. And here what we want to do is to point to the customer column that we want to compare. And here we need the customer ID, where we could provide and here customer ID. So this is going to select the customer with this ID and the column last name from the customer, and it's going to compare this column to this column of the discount, and it will bring the entity, the entry that has the same name with the customer, that has the same value with the customer column. So let's go here to our new method, new endpoint, and let's paste the ID of the customer, and let's execute, and we should receive, we received here the discount entry that corresponds to this last name using this method, this helper method. And also we have many other helper methods here that we could use. For example, this is the SQL equal. Let's go to a numeric value at the discount percentage. We can we have SQL average, absolute. Of course, this will not make any changes to this value because it's an integer, but we have SQL max. What SQL max does is it selects the row of the table with the max value of this column. Also there is SQL min. Okay, SQL absolute, and this returns a number. So this that runs the absolute function for every row, and we can compare this with a number, for example. All right, we can do something like this with the absolute. We have the SQL. What else we have? SQL. Wait, give me a moment. SQL minus. This is used to add a value for every row to this column. So let's say this column has a value, a different value in every row, and we want to add 5, and we want to compare this with something else. We want to see if we add 5 to this column, it will be greater than 10, for example. So this will only bring columns that have 5 or more, because that have 6 or more actually. There are plenty of things. I don't have the time to show everything. You can play around with SQL functions. There are also SQL functions, 2 SQL functions for the date. And order date, and we have a method. We have two methods here: the SQL date after, the SQL date before, and of course we have the max and the min. So if we want to check if something is later, let's say new date time here, and we can add some values here. This should work. So what we say here is we want all the lines of this table where the order date is after this date here. And we have also the SQL date before. That will bring all the dates that are before this date, and we have the min and the max where it will bring only one line and with the maximum date and the minimum date depending on the function. At this point I want to tell you that I managed to fix the problem with the descriptions. So in the next version, in the 6.0.3, you will have the descriptions of every method. As you can see, I found what was wrong. Here you can see in everything there's a description, and let's go and see some more features. Let's say you want to run a custom command. Let's delete this one here, and let's delete the whole endpoint. We will not need it. Let's say that we want to run a custom command, a custom SQL command. BlackHole provides another interface which is called IBH connection. So let's add this interface also here, IBH connection, and we can name it whatever we like. This interface is just an interface. It's not a connection. It doesn't create an active connection or something, so don't worry about using it in your projects. But I named it connection because I wanted it to look like the Dapper's connection, because it has the same methods as the Dapper's command connection. So let's name it connection. All right, and let's add this interface also here, connection. All right, and let's map it in the constructor. All right, we have no errors, and let's make new endpoint to test it. Actually, I shouldn't delete the previous endpoint anyway. And here, let's say connection test. All right, and let's return a customer here. All right, let's return all the customers. Okay, in a list of customer. So let's return get all customers, and here what we can do is return connection dot, and as you can see here we have query async, query first async, execute scalar async, and the simple execute method is the just execute that returns just a boolean that says if the method succeeded. So let's say now we want a query because we want a list of a generic item, which this generic item will be the customer. We also have a query first, which returns one generic item, not a list. And of course we have the asynchronous overloads for every method. And here we can say query, and we can say customer, and here we must add a command text, okay? And it has many overloads. As you can see, there is a class named bh parameters, where we can create here a bh parameters class. This is like dynamic parameters of Dapper. So bh params equals new bh parameters, and we create an object, and now we can add parameters here. We can add, and as you can see, it requires a name and a value. So let's say name. The name of the parameter will be last name, and the value will be, let's say, Mike. No, we don't have a last name for Mike. And wait, this is a name actually. It's a string. So now we have a parameter which name is last name, and its value is Arjolekas, my last name, and we could add here the bh parameters, and we can type a command select star everything from, and now we need, because we're using a schema, we need to specify the schema isop dot, and because we're using Postgres, and if you see here in the comments that I managed to fix, you have a tip here that says for Oracle and Postgres, double quotes are required for the table and column names in your command text. So if you're using Oracle or Postgres, here we need to add double quotes for the names of the tables and the columns, because BlackHole works like this. BlackHole is using double quotes only in Postgres and in Oracle databases, because in Postgres database, if you don't use double quotes, every table will be displayed and will be created with lowercase letters, and we don't want that. When we want the names of the tables to be exactly as the names of the entities. And in the Oracle, we have the opposite situation, where all the tables are created with uppercase letters. So we don't have this problem in SQLite or in MySql or in Sql Server. That's why BlackHole is using double quotes only in Postgres and Oracle. So, and here we want to add where, let's say, last name equals last name, since we have added this as a parameter here. So this should bring us a list with only one entry here, because we have two customers and only one of them has this last name. So now let our project run again, and let's test this endpoint now. It should return one customer in a list. So this is our new endpoint, the connection test. Let's try it. And we got this customer. We have a list, as you can see. This is a list, and it has only one object inside, which is the customer. So the custom command succeeded, And let's go back because I want to show you some more things about this. Here you can insert parameters, BlackHole parameters, but you can also add an object. For example, let's make a class here. Let's create a folder, generic classes, objects, generic objects. All right, and here, yes, we want to add a class. Let's add a class object, and let's say, come on, customer search object, customer search. Let's leave it like this, customer search. Okay, and here we can add a property, last name, public string, last name equals, no, not equals, get set. All right, let's say equals string empty for now because I don't like the warnings. And let's go back to our controller, and instead of these parameters we can create customer search, which we need to mention the namespace of the generic objects. So customer search equals new customer search, and here we want to add a value to the last name. So we got the value to the last name. Okay, and now instead of the BH parameters we're going to just use an object here that has a property that matches this property in our command. So if we run this again, we should get the same result. So let's go here, let's try our method and test it, and as you can see the connection also works with custom objects. So you can either add BH parameters here, or you can add an object here, and what you have to do is to use the same name as the object properties to your parameters in the command. So if I change something here, if I say if I remove a letter here, this will not work because it will not be able to find the parameter. Let's run it again and let's test it and try it and execute, and we have nothing, as you can see. So what else we can do? We can use a transaction, of course. We can create a BH transaction. Actually, let's do it like this. BH transaction equals, actually, you know what, I'm not going to execute this. Let's just make a transaction to see that you can also add a transaction here, equals new BH transaction. Remember to always dispose the transaction because the transaction has an active connection inside it. When you create a transaction, it creates an open connection. So you need to dispose the transaction every time. But the connection interface, the BH connection interface, it doesn't create a connection until it executes the command. And the BH connection interface closes the connection after the execution. But if you use a transaction here, as you can see, it has an overload to take transaction. If you are using this with a transaction, then the IBH connection interface doesn't create a new connection. It just takes the connection from the transaction. So you always need to dispose the transaction. And to do this, we could say var result equals this, and then we can say transaction dot dispose, and then we can return the result. Return, I said return. My fingers do not obey. Okay, something like this. So if we run again, this should work, and this should dispose the transaction and close the connection after the command is executed, and it will return the result here. Try it out, execute. Yes, sorry. I forgot that I have destroyed the command here. Sorry. Let's run again. Sorry for wasting your time. And now try to execute, and we get the correct result here. The last feature that I want to show you, but we will not be able to see it now because it requires you to have a fresh database, and it only works when you first generate the database. The new feature is let's add a folder here, right? And let's name this initial data. So the feature is, if you want to create a database and have default data inside when you generate it, let's say you have some user types and you want to have some default user types when you create the database on your production server, you can create any class you like and make it inherit from an interface. And of the BlackHole, let me show you quickly. Let's name this class default data. Okay, and we have a default date. Okay, default data. What data? Okay, yes, rename it. And here we can say using BlackHole.Services because it's in the services namespace. And here we can say, we can make this class inherit from the interface IBH initial data. And we are going to implement the method that it requires. Come on. So here implement interface. And what we have here is another class, the BH data initializer, which is it works similarly to the BH connection. So here we can say initializer dot execute command. All right, and here we type our command. We can type a command of insert, for example. We can create a stored procedure here. This interface, this method runs only once on the startup, on the creation of the database. So this will run when we create a new database, and it will never run again. You can execute a command with this, and you can also execute multiple commands from a file. So you can put the full path here of an SQL command file. Let's say you have your commands into an SQL file and you want to execute them. You need to separate your commands with a semicolon, and this method will take the file, will read it, and it will split the commands at the semicolon, and it will execute them one by one. So this is the BlackHole CLI, which is also available on NuGet. I have it already installed on my computer. It's a .NET 2. So you type this command into the command line, and you can install it globally to your computer, so you can run it from everywhere. The command you have to run to initialize the CLI is the BHL. I chose this command because it's short and it's unique, I think. I don't think there are other CLIs that are using these 3 letters. And this is going to stay at this version, because the CLI doesn't do anything else than just initializing the CLI commands that are already in the BlackHole library. So what this thing does is it detects the startup project in your solution file, and then it creates a temporary directory where it builds the project there, and then it initializes the correct command from the BlackHole library. And when the command finishes, when the execution exits, because if you run the BlackHole CLI commands, then the process will exit at some point. When the process exits, it deletes the temporary library and it cleans up again everything, all the trash that has created. So the commands, the current commands are these 3. It's the update command, the drop command, and the parse command. This is new, actually. I don't think any other ORM or any other CLI does parsing of a database. And let's jump right into it and see how it works and how you can use it if you want. It's not required. Let's jump right into it. And what I want to do here, as you can see, we have all our databases here. And what I want to do is actually I want to go in the program where we have the settings, and I want to delete the developer mode. First of all, I want to delete the developer mode. I want the BlackHole to be in production mode. And now we can go to the console of the package manager, right? And we can we can run our commands of the CLI here. And what I want to do is I want to try to drop the database. Okay, I want to try to drop the database. So I will type BHL space drop, and I will run this command, and let's see what happens. So it starts building the project into a temporary directory, and it runs. It says the database was successfully dropped, but if we go here and we refresh, we will see that the database is dropped because I didn't save the program. Perfect. Perfect. Perfect example. I didn't save this script. Sorry. So it was in developer mode. But we are given the opportunity now to recreate the database from the CLI. So let's clear and let's run b8cell update. So with this command, the b8cell space update, we are updating our database. We are doing exactly what BlackHole does on the startup of the project. And let's do the update. Okay, and now we can see all the commands that run to create a database: create table, create table, create table, create table, alter table, alter table. And we had an initial data command, default initial data, yeah, where there was no command here. We didn't add a command here. That's why we got nothing. But now if we refresh again, we have the database again. Of course, it's empty. It doesn't have these lines into the tables. So let's run this. Okay, and we have nothing here. And now, is everything saved? Yes, it is saved. Now I want to drop again. I want to try and drop again the database, but now we are not in developer mode, as you can see. So let's run the drop command. All right, and now we get a warning here which says BlackHole is not in dev mode. If you want to drop the database, either set BlackHole in dev mode or use argument F or force after the drop command. So if we go here and we refresh, the database is still here because BlackHole is not in dev mode, and also we didn't use the force command. So we have to do either we either have to set the BlackHole into dev mode or use the force command. I will run this again. Let's clear our console. I will run this again with the force argument drop, and you can either type dash force or you can type dash force dash f, sorry, and now it should drop the database. And as you can see here, this message, cleaning temporary directory has been cleaned. This is when it deletes the temporary directory that created, so it doesn't leave any trace to your computer. And if we refresh now, after this command, the database is missing. All right, now what I want to do is I want again to update the database, and I want to go back here into the BlackHole data folder, the default folder. And as you can see, we have no SQL files here, but this time I want to update the database. So to create the database using the save argument. So what I'm gonna do is say bhl update dash s, or you can do as like the force argument, you can do dash save. Okay, but for simplicity I'm just using dash s. And if I run this command now, BlackHole should generate also the SQL files of the commands that it used. So let's run this. And we can see that there are two SQL files generated here. And if we open this, let's open it with Notepad. And you can see we have a comment here which says the date, and it says create database, This is the first command that it runs for the database, and here it's the second command that creates the schema. And if we go here to the tables SQL, we can see that we have all these commands that were displayed on the console, on these commands. So if we copy and paste these commands somewhere else, we can recreate the database without BlackHole or without anything. And the next thing I want to do is let's go here to the entities, and let's add one more property to the customer. Let's say public string, what we can add to the customer, nationality. All right, it's set. Let's see the nationality of the customer, and I want to run again the update command. Let's clear our console, and I want to run again the update command using the save argument. So BHL update -s, and let's run this. So here it says creating, yes, the database is ready. Yes, because I didn't save. Wait, I didn't save the customer again. Let's run this again. You need to save everything before you run the CLI. Let's run this again. And now we should get this command. As you can see, we have this command which added the column nationality to our customer. And if we go again to our SQL files, you can see it has been updated. It has a different time, and if we open this file again, you can see this is the failed update that we ran earlier that had no changes, and this is the alter table is-shop customer and add nationality. So if you run all these commands again into a new database, you can recreate the database using SQL. Right? You must copy these. Actually, if you copy everything, because these are considered as comments from the SQL, you can copy everything and you can recreate the database. So let's do this. Actually, let's go here. Let's refresh and let's create a database. All right, let's say test BlackHole, again BlackHole test, just test, and let's see where is the schema. The schema. No, let's create this. We need to create a schema later, so let's save this, and here let's create a schema, and let's call it isop, because our commands contain the schema, so we cannot leave it out of the equation. And now what we can do, we can run a query here and paste all these commands here, as you can see, and if we run this, it should generate the tables, I guess. Yes. So now we have recreated all the tables of our database using the exported file of the BlackHole. And now it's time for the parsing. So what we can do now is run the BHL parse command. And what this is going to do is it will read the whole database that is referred to this connection. Okay, it will read the whole database, and it will check if it is compatible with the BlackHole, and if it is, it will generate all the entities into our project in a new folder that will be called BH entities. As you can see now, we don't have a BH entities folder here, and if I run this command, it should generate a folder with all the entities, meaning every table it finds, even the user table, it will put all the entities in one folder. And if we have an incompatible database, which as I said earlier is an old database or has compound keys or has different primary key names, it will not parse anything unless we use the force command, the force argument. Using the force argument to the parse command, it will try to parse every table from the database, but it will also generate a file with warnings and with the changes that we require to do before we run a BlackHole on this old database. But for now, we will not have this problem because the database we have is generated from BlackHole, so we run BHL parse without the force argument, and it's building and it's reading and it's creating the entities. As you can see, somewhere, let me see somewhere, the database is compatible with the BlackHole.ORM. Parsing has been successful. This is the message we get if the database is compatible, and as you can see here, we have all our entities, and if we open this, we can see they are in a different order, but we have all the fields, we have all the attributes. If we go to the order, I think I forgot to add the activator attribute. Yes, this is not able to parse it. It's unable to parse this attribute because the inactive column exists in every table. So I can't parse the use activator attribute, but I can parse the foreign keys and the varchar size and the not nullable. As you can see, everything is here. All our entities are here, and they have the correct type of ID. And now if I delete this, if I delete the entities and I change the references in the controller, I should be able to run my application normally. But I'm not going to do this because I want to keep the project as it is, to use it as an example project on GitHub. So let's delete these entities that were created here. Let's clear. And what we want to do now is we want to use the rest of the databases. So if we stop Postgres and let's close the pgadmin, we're not going to use it anymore, and let's start with the Sqlite, for example, which has a different configuration. So let's go here and let's say connection.use Sqlite. What we're going to do here, what it requires here, as you can see, now that we have the description, it requires the database name. It doesn't require any path or any connection string. If you are using Sqlite, because it's a single file, it gets created here in the BlackHole default data folder. Here we have a parsing report, which has no errors because the database was compatible. But if it finds some errors, it will show them here. And as you can see, there are three levels of errors: the minor, the medium, and the high. The minor and the medium are easily fixable, but the high parsing errors referring to compound keys that BlackHole doesn't support yet. The medium is maybe error in name, and the minor is maybe the inactive column is missing, which will be automatically created if you have only minor errors. It's fine, you can proceed. It will just generate an inactive column on each of your tables. So here, back to our subject, the SQLite initialization. Let's use a name here, testing DB. We don't even need to add the extension of the file, we just need the name of the file. And if I run this now, we should have a database created here in a single file. And if I open this database with this tool that I found online, so let's open this file. As you can see, it's an SQLite DB3, it's SQLite 3, so it's also compatible with mobile. And as you can see here, we have our tables, we have everything here, and of course we can also run the previous commands. So what was that? It's let me remember really quickly. It's post insert customer. All right, let's run the post command to insert a customer. Execute, and the customer was inserted. We got the GUID ID back. So even in SQLite we have GUIDs. We can insert and read GUIDs. Also in Oracle we can insert and read booleans without any extra effort, because if you know SQLite and MySql and Oracle don't support directly UUIDs, and Oracle also doesn't support booleans. It supports the number 10, but everything is handled automatically from the BlackHole, so you don't have to worry about any of this. You can just create your project, use the data types of the properties that you like, and BlackHole will work out of the box with any database. So we have inserted here the customer. Let me see now. Here, let's go and browse data, and as you can see, we have the customer. And now what we want to do is I need to change this method here because I want to bring all the customers. All right, let's say query. Let's remove the where statement. Let's remove the schema, and let's remove the double quotes, because we, as I said, we don't need double quotes for SQLite. Okay, and also we don't have a schema in SQLite. We have only a schema into also, why I'm deleting the transaction, I don't know. We only have a schema into the Postgres and to the SQL Server. So let's delete all of this. All right, let's get all the customers. All right, let's run. I will insert a couple of more customers just to get a bigger list. So let's post, let's insert more customers. As you can see, we're getting a different GUID every time. So let's insert multiple customers, and if we go here and refresh, you see we have many customers. Of course, they all have the same values in the columns because we are using we are using the same generator, but they have different IDs because BlackHole is generating a new ID for every insert. And now we can go here and we can say connection test, I think, if I'm correct. And let's get all the customers. And as you can see, we got all the customers and we have the GUIDs. The GUID was translated into GUID into C# without any problems. And we can do the same exact thing for each database. So that's what I'm going to do now. I'm going to close the SQLite and I'm going to start another database. Let's start a MySql. All right. And now let's go to our program settings and change this to use MySql. Also, MySql doesn't support a schema because the schema is the name of the database. So use this. We should use also we can also use the CLI to update and create the database. Update, BSL update. So this will create a database on MySql. And as you can see, the database is created. We also have the same tables. Is anything missing here? So after a little bit of troubleshooting, I found that the command, the name order is for some reason used from SQL, and it gives me an error when I try to create a table with the name order. So if I write orders, it's fine. So what we're going to do now, we are going to drop BHL drop force. We are going to drop the database. Okay. And we are going to rename this to orders. Okay. Let's refresh here. Let's make sure that it has been dropped. All right. The schema is gone. And now we are going to rename this into orders. I don't know. MySQL has many weird problems. So now we are renaming this. So clear BHL update. Let's run this again. Now it should run. Okay, no errors. And now it creates a database. And now if we go and refresh the MySQL workbench, we should see all the tables in there. Perfect. So now we can run. Weird errors happening sometimes into some databases. Okay. So post, let's create some users, and we are getting a different ID each time because BlackHole is generating a new user, and as you can see, it's very fast. So let's go to the customers, actually not users, customers. Let's select everything, and we can see here that we have all these customers with their GUIDs, and we can also select them, and the BlackHole will map the GUIDs to C#. So let's test this, let's execute, and we are getting all our customers. Okay, so it also works on MySQL. Now let's do the same for the rest of the databases. Let's go here. I have an instance of Oracle. BlackHole does not, let me close this one. BlackHole does not create the database of Oracle. You need to install the database because its database in Oracle is like standalone server. So now what we are going to do, we're going to stop this, and we are going again to change the connection string. Let's paste this here, and let's change the use of the database, use Oracle. So this should generate the database in Oracle. Let's clear, and we can either run, or we can let's run a drop command first, because I don't know if I have an existing database there. So Oracle has every schema connected to a user. So its account has a separate schema sometimes. That's why BlackHole does not support schema with Oracle, because the schema is included in the connection string. BlackHole is searching for the username of the connection string. And now, as we can see, we don't have any tables here. Let's clear our console. Let's run BHL update, and we will create a database on the Oracle, unless we have other problems this time. I don't know what Oracle doesn't like. And if we refresh here, we have the tables. And let's go to the order, because I want to show you something. If we go to order and we go to the columns, and we have a boolean here which says delivered. It's a number 10, because Oracle doesn't support booleans, and the BlackHole will automatically translate this into a boolean, into C# onto your entity. So you don't have to worry about this. Also, we have here a string ID, and if we go to the customer, I think customer has a GUID. So if we go to the customer, you can see we have a varchar2 is a string. So the BlackHole translates the GUID into string, and it's 36 characters long, because that's what is required to work correctly. And then BlackHole also parses the string into GUID when you select something from this table. And let's run again. Let's do the same process to insert a customer and then try to read the customers. So you can see that the GUID works. And we can either use a breakpoint into our controller. We can go here and add a breakpoint here, so we can see the result of this query. And let's also go here and create some customers. As you can see, we got a correct response. That means our customers are inserted into the database. Let's go to the Oracle developer. Let's go to the customer, to the data, and as you can see, we have the customers here. And now if I run the select command here, try it, execute, and here we will get a list of customer. Come on, show me. We don't get a list of customer. Oh yes, we don't. And the reason for this is we didn't use the double quotes. As I said, we require double quotes for Oracle and Postgres. So let me fix this quickly, and let's run again. So now we should be able to get a list of the customers. The command here, try it, execute, and now we should get a list of customers. As you can see, we have nine customers, Everything is mapped correctly. We have the GUID here. This is a GUID. If we open this, no, I don't think I can see the data type here. And let's continue. And we got the result in our Swagger. So that is pretty much how BlackHole works. I could also test the SQL Server, but it's the same. We'll get the same results. So this is my website. Here you can find everything about BlackHole. There is an online documentation here. I will have a link in the description. You can see there's documentation that explains every namespace. And if you go here to the data provider, you have all the methods, and you can click, and it opens here a list with the methods and the overloads with some examples. So I will have a link I will put a link in the description of this video. There are also the social media here. I will also have a link for the BlackHole.Core.ORM on NuGet. I suggest you to use the 6.0.3 version, which will be released with this video, after this video is released, and it will have the descriptions of the methods and some minor fixes, some minor bugs that I found and I fixed on the SQL functions. And of course here is you can find it on GitHub in Microsoft, and also you can find the CLI here. Thanks for watching. This was an almost complete tutorial of the BlackHole Core.ORM, and if I add some new features in the future, I will make an additional video. Bye.